Earth was formed because of impact events. We have to understand what the Earth is made of in order to understand how are deep earthquakes happening, what is happening in terms of volcanism around the globe. So an impact event is when a rogue space rock hits the surface of the Earth or the Moon and essentially leaves a big hole in the ground. On a daily basis, about 100 tons of space dust, sort of sand-sized particles, are bombarding the Earth's atmosphere. If you go outside and eat your lunch outside, by the time you came back inside, you would probably have some space dust on you. About every million years or so, a very large impact event might happen, which could actually cause significant damage to the global environment and life on Earth. And so an example of this kind of event is the Chicxulub impact. The energy that was this kinetic energy of the impact flying through space and flying through the atmosphere, it gets converted into intense heat and pressure. Those old atomic bomb tests where there's this huge mushroom cloud, this huge explosion. It's that, but many, 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 many times bigger than that. You would not want to be around. This vaporized rock, melted rock, as well as some solid material flying away from the site of the impact originally in what we call an impact plume. And the thing that I do in my lab is I want to replicate that impact plume condition. So in order to do that, I need to be able to have molten rock. You might put a piece of rock or some powdered rock in some kind of a crucible. There are problems with this because when you are doing experiments at very high temperatures, you might run into a situation where you have a chemical interaction occurring between your sample, your experiment, and the actual container that's holding it. You might be trying to reach temperatures at which your container would start to melt. And then you've got a whole nother level of contamination on your hands. I use a high temperature conical nozzle levitation system. You start with a relatively small sample and put that inside of this specially designed nozzle, which has gas flowing from below. Your sample then starts to float a little bit off the surface. And then what you do is you turn on a laser, which is directed to interact then with the sample. And you adjust the laser power until you reach the desired temperature that you want your melt to reach. In my lab, we routinely reach temperatures of about 2,500 degrees Celsius. My name is Macris, but I go by Cam. I levitate lava orbs in my lab.